Hello, this is the fourth part of chapter 6.5, and we will talk briefly about the alternative method for calculation least square solutions. And this particular method is appropriate when our matrix A has a columns which are orthogonal, which happen to be actually pretty often in real life. So in this case, because they are orthogonal, we can just expand our right-hand side B along the basically basis of given by the columns of A. And let me just show some example. For example, let's find the least square solution of our matrix equation AX is equal B, and for the given matrix A and B. And again, you can easily show this system is inconsistent, so we do need to solve it, find an approximate solution. And here we have matrix A has two columns. Let's call them A1 and A2. And those two columns is actually orthogonal. And we can easily show this by calculating the dot product of matrix A1 and A2, and it is equal 0, so they are orthogonal. And because they are orthogonal, we can writing down our vector B in the basis of columns A. It's just a simple formula which we learned a couple chapters ago, and we can find the first we can find the weights using the dot products and numerator and denominators. Then we substitute actually the values for vectors or columns A1 and A2 and find our approximate right-hand side vector B hat. So it's just a different way to find the projection. Okay, so now when we have our right-hand side vector B, we can just solve our matrix equations. And because we are already expanded by the basis B, the solution is really easy to find. So the first component of our vector X hat is just the weight in front of our vector orthogonal, first orthogonal vector A1. Our second component of vector X hat is the second weight in front of the orthogonal component A2. So that is rather easy operation. So if you happen to have a matrix A orthogonal, then the solution would be much more easier for you. And there is several examples at the end of the chapter when you can apply this method, and I'm sure you'll enjoy doing this. It's much easier than solving normal equations.